At the LINNC we have done 4 live cases this year with different type of devices to show to the physician the field of possibilities we offer with the software. We can size a flow diverter, we can size endovascular devices, and the goal is really at the end to standardize the procedure, the sizing step of the procedure. In this way we can secure the treatment for the patient, and through a medical economic study we have done, we demonstrate that we reduce the cost also for the hospital at the end. All the time the device you choose with the software was a good one for the patient. So it's one device per surgery all the time with SIM&CURE up to now. And what we observe, we also reduce the size of the device they use. That means that's less metal for the patient, so we reduce the thrombogenic risk. Because the device is shorter, the navigability is improved and the deployment is faster. So we also reduce this step, and for the physician it's really, really better to treat this patient in this kind of conditions. Our goal is really to help the physician to anticipate all the gestures he will have to do to treat the patient. So we help him to define the size but also the position. So that means he knows where he has to start the deployment and where he will finish. And for him, it's a great advantage, and we remove a lot of pressure on his shoulder by doing that. We use the medical images from the patient and we reconstruct in 3D the cerebral tree. After that, in parallel, we have some database of mechanical behavior of the devices and we integrate that inside the software. In this way, we can perform patient-specific computation, but also device-specific computation. And that's why we are able to provide a very accurate result for the physician with a high level of accuracy. The tool was designed by physicians for physicians. It's a very simple interface, very user-friendly. It's only 5 or 6 clicks to obtain the results in less than 3 minutes now. So it's very easy to the physician to perform his own therapeutic planning with the software. Our goal for next year is really to duplicate what we have done in Europe, in Asia, in South America. We are looking for the FDA approval now to enter in US at the beginning of next year. And we also look to other pathology where we can duplicate what we have done in neurovascular. And we truly believe we are able to duplicate that in all the endovascular procedure. Now what we try to do is to identify which kind of pathology could be a good next challenge for us. The goal is to start to help them to plan the complex cases, but after our goal is to become a standard of treatment. That means for each procedure you perform a simulation before to be sure everything is okay and to secure the treatment of the patient. That's the idea we promote through SIM&CURE. Now what we are looking for is for the follow-up at 1 year of the patient, because we want to see if the impact of a better treatment, a better therapeutic planning could have an impact on the retreatment of patient. And up to now we have about 20 cases in this study who have no retreatment. So for us it's a huge advantage because we know another treatment for the patient it's always a trouble and another cost for the healthcare system.